Hey, welcome back. Ralph here again. This is Network Plus domain 2.5, which is given a scenario, troubleshoot common router and switch problems. Okay, so there are typically a lot of scenario slash problem based questions on the exam, and one couple of pieces of advice on those types of questions. One, you're probably not going to get to a point where you are completely certain of an answer. I mean, some of this is a little bit subjective in how you read the question. And so, my typical general rule of thumb is, once I'm about 75% sure that that's the right answer, I answer that and I move on. There's a lot of times when you may not get to that 100%, but that's okay. Answer it, forget about it, move on to the next question. And the other thing is that read these questions carefully. And if they say there's a problem with a particular device, like they say there's a problem with the router, then your answer should address the router in some way. Don't select the answer that talks about fixing the switch if they tell you there's a problem with the router. So it's important, your experience, that you have, through working with networks is going to be very beneficial to these types of questions. Treat them like how you would treat them in the real world. That if you have good troubleshooting skills, and that's the appropriate way to approach these questions. Think about, well, if I really had this problem, what would I do? And again, figure out what has the problem and what's the most likely solution to fix that particular device if it's a hardware issue. So let's go ahead and take a look at the actual objectives and make a couple notes on those. Let me go ahead and get my screen shared out. Okay, so here it is. Objective 2.5. Given a scenario, troubleshoot common router and switch problems. And the first thing that they talk about here is that they talk about switching loops. Okay, so what happens when we have a switching loop? Well, let's do this. Get rid of that, and let's draw a quick little switch. Okay. So our switching loop might be all on one particular switch, or it could be that we have multiple switches in our environment and somehow somebody has connected it so that we have a loop. So let's quickly draw a switch here. All right, so there's two potential scenarios here in terms of our switching loop. One would be we could have a situation where somebody just connected a wire like that, okay? Or we could have a situation where someone connected the switch here and then they also connected the switch here. Either way, what a switching loop, Cisco describes a switching loop as a catastrophic problem. Okay? And the reason it is a catastrophic problem is because and we talked about in the STP piece a little bit earlier, that there is no loop protection built into the frame header. So when we're talking about switches, we're talking about frames, we're talking about layer 2 devices. And so what happens is that when something gets caught, a broadcast gets caught in a loop, it never stops. Okay. So whether it's here or here, and then another broadcast gets caught in the loop, and it never stops. And then it never stops. And eventually the backplane on the switch is going to get so saturated with this broadcast traffic that it will cease to function properly. Okay, and this might take a very short amount of time, or this might take a minute or two. But when you have a connection like that, when you have a loop at layer 2 and it's an unmanaged switch, your switch will stop functioning. Now we also, but make note that we do have loop protection at layer 2, not built into the header, but if we have managed switches, then the spanning tree protocol, okay, should take care of detecting and blocking any loops from occurring. So spanning tree and the spanning tree protocol, when we have managed switches, is going to prevent switch looping from occurring. All right. Now, when we have unmanaged devices, then that's when we have to fix the loop before we can get going again. The next subject there, they talk about bad cables or improper cable types, and so that's a pretty generic statement, right? I mean that if you got a bad cable, that can either cause no connectivity or that can cause intermittent problems, because it's not the appropriate cable type or the cable has some damage. I don't know exactly what kind of note to put on that, but cabling is certainly a very common issue when you talk about layer 1 problems. Cabling is exposed, and so it's more likely to get damaged than lots of other things. From a port configuration standpoint, so when they talk about port configuration, they're definitely talking about switch ports here, okay, because that's what the objectives say. So we're talking about the ports on the switch, okay, and the different things that we configure at the port on a switch would be things like the speed, okay, or we can configure duplex, okay. And so if we get a mismatch, a speed or a duplex mismatch, that's going to cause us problems, okay. Other configuration, ports can be disabled and things like that, but that's probably where they're going with that particular comment there, that we have a speed or duplex mismatch, and that's caused by us making a improper configuration on the port. Now, VLAN assignments. So VLANs are our broadcast domains. We talked about those a little bit earlier. The VLAN assignment can be assigned in a variety of different ways, but probably they're talking about like a port-based VLAN assignment. So in a port-based VLAN assignment, I'm assigning specific ports on my switch to a particular VLAN, okay? If I do that improperly, okay, so I think that I assigned, this port right here to, let's say, so I thought I assigned this port here to my blue VLAN, or my red VLAN, but it's actually in my blue VLAN, so this node that I plug into it is not behaving correctly, but that's because the VLAN assignment is wrong on that particular port. Okay, so that's typically just an administrator mistake. So, but again, VLAN assignment, especially at the Network Plus level, we're probably talking about VLAN assignment on the port level. Okay, so that the port was assigned to the wrong VLAN, therefore the computer's not behaving correctly. It's not connected to the appropriate other nodes in terms of its broadcast domain because of a poor VLAN assignment. So this MTU, or this maximum transfer unit. Now let me pop open this little. So here's a Linux box here, and I'm just going to run an ifconfig, and you'll see one of the things that they mention on the interface here is these MTU. And typically what you'll always see is this maximum, basically the maximum frame size. MTU is 1500. Okay, so what they're saying here is that if that information is configured incorrectly, so I've got a router, okay, and this router, has an MTU assignment that, a non-standard MTU assignment, 1200 or something, which is very unlikely that you would see, but just throwing that out there. And so when a packet comes into that router, okay, and this packet's 1500 bytes in length, this router will discard that, okay, put it in the trash. Okay. So this idea of a black hole is that we're sending information into this router. The router has a misconfiguration on its MTU, and then therefore all of those packets that fall in, those very large packets, are just getting dumped into this black hole, into the garbage can. The router's looking at it saying, oh, I can't handle that. All right, so that's what they're talking about there. The power failure is power failure. Okay, not much to say there. If you don't have power to your device, it's not going to work. The bad or missing routes. Okay, in order for a router to route, and we learned this in the routing section, in the routing review, the router has to have a known path to the destination network. So the router looks at the packet header, the IP header, and says the destination network is 209.69.255.0. Okay, do I have a path? Now, most of the time, if we're going to run into issues with bad or missing routes, it's going to be associated with this idea or this concept of the default route. Okay. So on a Windows box, we would call it, the default gateway. And what this is this is a route that represents, all other networks. Anything that doesn't specifically appear in the routing table goes to the default gateway. So that's what we call it in Windows. We call it the default gateway. On a Cisco router, we would call that one of two things. We would either call it the default route, or we might also, you'll see it referred to as the route of last resort. Same thing here. Now, so what happens is if we forget to define that, everything that's not specifically defined in the routing table doesn't get routed. The router just drops it because it doesn't know what to do with it. So if we have a missing route and it's causing problems for us, it's usually, the default route. Okay, but it could be, we could also have bad routes, incorrectly configured static routes and things like that. But so the only thing the router can use to make path decisions when it's routing packets is the routing table. Okay, and if the information in the routing table is not accurate or the information is missing from the routing table, then that information cannot get routed. It won't get to its destination. Okay, the bad modules, the gigabit interface converters, these are again, these are associated with modules that we put in our router for interfaces, and again, if they're, it's really just a faulty hardware thing, and so if the hardware is bad, then it's not going to work. Okay, and then the last four really deal with software configuration. Okay, so all nodes on the same network should have, as part of their IP address, should have the same IP, network ID, and the same subnet mask. Okay, so a situation where we have a wrong subnet mask. Let me kind of draw up a scenario here. Okay, so this actually happened in our environment, and I'll show you what happened. So the administrator went in and statically configured the devices. Okay, and so it was 192.168. It was in room 3. So he's giving them static addresses. So that was the address. Okay. And then gave it a subnet mask. Okay. And gave it a gateway, 192.168.3.251, and that was the default gateway. And then the DNS server was server out on the backbone, 192.168.20.3. Okay, and that was our name server for DNS. And all of a sudden, couldn't browse the web. But when you tried things like, for example, if you said ping, 8.8.8.8, a Google web server, Google DNS server, and that worked. Okay. But then when you said ping www.google.com, it failed. Okay. And this is an example of a wrong subnet mask. Okay, well, what's wrong with the subnet mask? So what's wrong with the subnet mask is that it's a 255.255.00, which means that the subnet mask defines what portion of the address is the network ID. Okay, so in this particular scenario, the network ID is the first 2 octets, 192.168. So there's my default gateway, my router. That has to be local to me. That's on the same network. But the reality is that when we look at this, the DNS server is not really on our network. The subnet mask should be a 24-bit mask. Okay, so but really our network ID is 192.168.3. But because we only said the first 2 octets, it's looking for the DNS server locally, because it thinks the DNS server is on the same network, because the DNS server's address starts with 192.168. So it's looking around for that on the local network, and it's not finding it because the DNS server is actually on our backbone on the 192.168.20 network. But because we misdefined the subnet mask, it can't find it. It thinks it's local. So that's an example of the wrong subnet mask. Wrong gateway. Your gateway is your router address. If you're pointing to the wrong device to route you, you're not going to get anywhere. Okay. That's a pretty basic one. Now, the one thing I will say about the wrong gateway, and one comment on that, is that your gateway is always local to you. It's always on the same network. If it's not, you can't find it, you can't use it. Okay? And that's a pretty common gotcha that they go after. They show you a little diagram and they put the gateway on the wrong network. Okay? And the gateway, whatever your network ID is, like for me, 192.168.3, whatever the gateway has to have the same network ID. Okay? Or else you can't find it, you can't use it. The default gateway has to be local. Okay? Two machines have the same IP address. That's going to cause communication issues. Everything has to be uniquely identifiable in a TCP/IP network. Okay? So that can mess up your ARP tables and a variety of different things. And if you're pointing to the wrong DNS server, then the result of that is you get failed name resolution. That's the bottom line. Okay? If you're not pointing to the right DNS server, then you get failed name resolution, and you won't be able to access anything by its name or its URL. So again, this is, it's fairly short. Again, I really recommend that you take your time with, with these types of, questions that you run into on the exam, and really try to figure out exactly, what device is having the problem. And your answer needs to address, that particular device. Hope you found that useful. There's not going to be a quiz associated with this section, but just want you to get you thinking and review a few of the potential scenarios that you might run into. We'll see you guys in a little bit.